Hello class, this is a video tutorial on Pythagoras theorem. In this video, we'll be looking at mixed problems using Pythagoras' theorem. In previous lessons, we used Pythagoras' theorem to calculate either the missing length of the hypotenuse or the missing length of the short side. So in this video, we'll be looking at problems that will be mixed. So it's not always straightforward as to which of the two we have to use, but you'll see through these examples that if we just follow the Pythagoras' theorem, which I hope we can recall was c squared equals a squared plus b squared, where c is always the hypotenuse, and these two are the short sides. And you'll see if we just follow this Pythagoras' theorem, placing the correct values in the correct positions, it becomes very obvious which method we have to use. So here we go. So now for all of these, we know that these are right-angled triangles, as we can see here. There's a little box. And before we even begin, I'm going to place this as, well, I'm going to write out our formula. C squared equals a squared plus b squared. Now let's not be confused that A and B correspond to the letter A. Remember that C in the formula is always the hypotenuse. So the box is pointing to our hypotenuse. So in this problem, A is our hypotenuse, so A squared equals, and the two short sides, A and B, are the two short sides. In this case, it'll be 3 and 4. So it'll be 3 squared plus 4 squared. A squared remains the same because we can't type that in our calculator. However, 3 squared plus 4 squared we can type in. So 3 squared plus 4 squared. When we type this into our calculator, we get 25. And then from this point, we take the square root of both sides. Square root of 25. So A gets us, so we now go square root of 25, and that gives us 5. So the value of A here is 5 centimeters or kilometers or whatever it might be in the problem. Now let's take a look at our second problem here. Once again, just always beginning with our formula, c squared equals a squared plus b squared. We can see from here, 29 is our hypotenuse. So 29 belongs here in our formula. So 29 squared equals, and a squared and b squared, well, that's the two short sides. So instead of a squared, I'm going to make this b squared. And instead of b squared, I'm going to make this 21. Of course, you can switch these around, as in you can make it 21 squared plus b squared. It's not going to make a difference. And now we're going to evaluate our values. For this, I'm going to make 29 squared in our calculator. Oops. Let's type that in. So 29 squared is 841. B squared remains the same. So it stays as b squared. And 21 squared is 441. And now from here, this is just a basic quadratic equation. We want b squared on its own, so I'm going to subtract 441 on the right-hand side and subtract it from the left-hand side as well. So in our calculator, we can find that. So 841 minus 441, which gets us 200. So this is equal to 200. And since these two cancel out, all we are left with is b squared on the right-hand side. Then from here, I hope you can see, it's at this same step. We're now going to take the square root of both sides. I'm going to write this now as b equals square root of 200. And we can type that into our calculator. So square root of 200. Square root of 200 is, well, in this case, we get a decimal value. This gets us 14.14. And since we're rounding to 2 decimal places, we say it's approximately equal to that. And we write to its right that we're indicating that it's rounded to 2 decimal place values. All right, so I hope you're seeing that we're literally just using this formula, placing the correct values in the correct position, and then solving the problem. Okay, so you can pause and give this last one a go yourself. So here we go. Once again, always beginning with our formula, c squared equals a squared plus b squared. C squared, in this case, remember, is our hypotenuse. So the box points to our hypotenuse. So in this case, c squared does indeed remain as c squared, where 12 and 35 go into the positions of a and b. So this becomes 12 squared plus 35 squared. Notice how in this one, they're both these numbers are on the same side. So c squared remains on its own. And this is what we can type into our calculator. 12 squared plus 35 squared, which gives us 1369. And then from here, we take the square roots of both sides. So square root of 1369. And that we can type into our calculator. Square root of 1369. It's exactly 37 and centimeters or millimeters, whatever it might be in the problem. All right, so I hope that's giving you an insight into this first set of problems. I hope to see you in the next video where we tackle another set and some worded problems on top of that. Hope to see you in the next video, and best of luck.